Hello, welcome back to Algebra. Here we're going to wrap up the concept of polynomial long division. The problems are going to be a little bit longer because we'll be dealing a lot of times with third, fourth degree polynomials. And also what we're dividing by, the divisor, we're going to be making those a little more complicated. So it doesn't change the procedure, it just changes the number of multiplications you have, and so on. You'll see as we go that the process is the same, but it leads to the problems being a little bit more involved. So what we have for the first problem is 15z cubed minus z squared minus 11z minus 3. And we want to divide that whole monster by 3z squared minus 2z minus 1. So in the previous problems, the polynomial we're dividing by, which we call the divisor, on the bottom here was simpler than this. In the past, they were all like t minus 4, t plus 3, maybe 2t plus 1. Here the divisor is a full-blown polynomial with a degree of 2. You can divide any polynomial divided by any other polynomial. The degree can be very high or very low in both of those locations. But when you have higher exponents, it leads to the problem being a little bit more involved. So for instance, we're going to rewrite this one as we expect. 3z squared minus 2z minus 1. That's on the outside. And on the inside, we're going to have this thing, 15z cubed minus z squared minus 11z minus 3. All right, so we give ourselves some space. We have z squared, z to the first constant term, z cubed, z squared, z to the first constant term. So we're not missing anything. So we don't have to put any zeros in. So that part's good. And then we're going to tackle it the same way. We only look at the very first part of the divisor and the very first part of what's underneath. And 3 times 5 is 15, so we know we're going to have a 5. And z squared times something is going to give me the z cubed. It has to be a z there. Then we take this and multiply. Again, we're going to get 15z cubed. And then the 5 times the negative 2 is negative 10. Z times z is z squared. Has to match what's above. And then 5 times the negative 1 is going to give me negative 5, but then you have a z times that as well, so you're going to have a z. Now you have to subtract these. Now the 15z cubes subtract away perfectly. Now we have to subtract both of these. We start with this one. This is a negative 1z squared, negative 10z squared, but we're subtracting it. So it's negative 1 minus a negative 10. So it's negative 1 plus 10. Negative 1 plus 10 is positive 9. And the z squared comes along for the ride. Okay, now we have to subtract this. It's negative 11 minus a negative 5. So it's really negative 11 plus 5. If it helps you, just go over here and put negative 11 plus 5. Then you can think about that, and you can see it's going to be negative 6, and then the z is going to come along for the ride. So you've subtracted this column. Well, you've subtracted all of them. This gives you 0. You subtracted this, and then you have to drag, after you do the subtraction, the last column down. You always drag the next column down there. Then we look again at the first terms. 3 times 3 is 9, so we have to have a 3. Z squared times 1 is z squared, so I don't need to put anything there. Now I can do my multiplication back. 3 times the 3z squared is 9z squared. 3 times the negative 2z is negative 6z. And 3 times the negative 1 is negative 3. Okay, so we're going to subtract here. So look what happens in this case. The 9z squared minus the 9z squared gives you 0. The negative 6z minus the negative 6z gives you 0. The negative 3 minus the negative 3 gives you 0. So you have 0, 0, 0 everywhere, so really you have no remainder left. So this is a perfect example of when you would say 15 divided by 3 is 5 with no remainder. So the polynomial divided in, and there was no